Hello learners, welcome back to my channel. I am Sivathmika Chavali. This is my YouTube channel. If you find my content helpful means please make sure to subscribe. Today I am gonna solve LeetCode 513 find bottom left tree value. So I am gonna solve but I don't explain. See, what's the difference is I will solve and I will put my random thoughts like how I'm gonna solve this problem in that way. Okay, and I don't explain this problem, so please feel free to watch this video up to end. You will get to know how I'm going to solve this problem. And if you have any suggestions means please make sure to comment in the below, like you can if I can do this problem in more optimizer way means please make sure to comment it. And I'm a learner, and yes, let's do this problem. So here what we have to do means we need to return the left tree value, last row of the left tree value. See here, return the leftmost value in the last row of the tree. Okay, here you can see 2 1 3 and the 1 is the last in the last row, 1 is the left side, right? So 1 we need to return, and the return type is in. Okay, in the same way example 2, last row and the 7th one is the leftmost value. Okay, ranges are 1 to 10 power 4. How can we solve? Like, so my approach would be like around see, if you take this one, let's take the first example itself. No, let's take the second example, it would be convenient. 1 2 3 4 5 6 7 1 2 3 4 and 5 here, 6 here, and here the leftmost value is 7. So clearly they mentioned in the problem like leftmost value in the last row, they mentioned the last row. So how can we get how can we know that this is the last row and return this leftmost value? So if I say this is the first row and this is the second and this is the third and this is the fourth, so when it reaches to the fourth row, just return the left value. This is the way I'm thinking. This is my thought process. Okay, so here, okay, we can find the depth of the tree node. We have one separate problem also to find the depth of a tree node. Okay, let's find the depth first. By using level order technique, I will find the depth of this subtree, I mean this binary tree. Q tree node, Q equal to new link list, and here I am adding the root one. If the root itself is null means just return 0, nothing, it should return 0. And let's give int depth is equal to 0, and while not q dot size no, while q dot is empty. If it is not empty only, you need to loop. Okay, is empty. Now it will take q dot add root, right? So root will be in our queue. So if it is the queue, our root is there in the queue already. Let's take the size. Int size equal to q dot size. Yes, so we will get the size count as 1 because only one root itself is there in the queue, so size is 1. Okay, now let's take the for loop for I equal to 0, I less than size and I plus plus. Okay, now we need to call that one, I mean remove that element which is present in the queue. So let's say n q dot poll poll, that means when that line execute means q dot poll. So whatever that is present in the first index, 0th index, that it will be removed from the queue. So 1 will be removed and it will be initialized as n here, as we mentioned. Okay, now I need to add, if n dot write not equal to null, just add it into my queue, n dot write node. If suppose n dot left, okay, first we need to add left, right? We are going level order traversal in left side, okay, left, and here left. If n dot right not equal to null, just add q dot add n dot right. Okay, but what we are doing, we are finding the depth first. That means how many rows are there. We are finding the last row. So let's, here itself we can increment the depth plus plus. So now I will get my depth. I will get my depth. Okay, so let's return the depth. Let's see whether it is returning correct or not. See, I'm returning the depth here. For this example 1, the depth should be 2 because this is the first row and this is the second row. And the example 2, the depth will be 4. 1, 2, 3, 4. Okay, we should get these outputs. Okay, we got depth 2. It's correct. And the next one should be 4. Yes, 4, it's correct. Which one? Okay, so this is my case. Okay, case 3 is okay, fine. Now I got my depth. That means how many rows are there in our binary tree, I got to know. Now my last row, I can clearly clearly get my last row from this depth. Okay, it might take huge time complexity, right? Because again I need to use the queue. Any optimized approach can I use for this one? Okay, let's see. Now I got my depth. So now the depth value is 4. Guys, I didn't do anything. I just did level order traversal. In the level order traversal, I just incremented the depth so that I can get how many rows are there in our binary tree. That's it. This is the level order technique. And now for the main problem, like we need to get the leftmost value in the last row, right? So if suppose let's say I'm taking index, okay, and I'm initializing 0. If index is equal to depth means just return the element which is present in the queue, that is the leftmost, right? Now again I will traverse in q dot level order traversal. It's not a optimized approach. I mean, if you guys know anything optimized approach means, please feel free to comment. So editing, do we have any other approach? So what my plan is here, so I got my depth, right? And again I will traverse from starting onwards, like level order traversal. So in the level order traversal, see here, again I will initialize my queue. I mean this queue only I will use. See here, again I will add the root node into my queue again. So again the queue will be 1, it holds 1, and again the same pattern repeats, level order traversal. So but here we will keep if index is equal to depth. If it meets the last row means that is the thing I am doing, and here index plus plus, so it will increment the index value. And then after what can I do? Okay, level order traversal, let's copy this one only. So int size is equal to this one, let's copy this one. So this is the thing I want to try. So let's see how it works. So basically here what I am doing is, now index is 0, right? Firstly I initialize index value as 0. Now in queue our 1 is there. According to this example, one root node is there. Now again, is queue is empty? No. So while loop will execute. Now queue will be size. It takes the size as queue dot size. What is the queue size? 1. Now here 1. Now again the for loop will execute. It will poll our queue. So now queue will be empty and n will be 1. So what is the thing? Root dot right is 3, root dot left is 2. So 2 will be added into our queue. Root dot right is 3. 3 will be added into our queue. Okay, and next one. So now the size will be 2, right? In the meanwhile, index will increment. Index value is 3 now. Now 2. Index value is 2 now. Previously it is 1. Now it is 2. Now queue's first value is 2 and the size is 2, right? Now it will poll, right, and it will take 2. Now it will check for the 2. Left is there, 4. It will add into the queue, but right is not there. It will do nothing. And again for loop will execute 2 times because here we gave the size, right? So that's why. Now the 2 size, again the for loop will execute. Now 3 will holds the n position, n variable. Now it will add the left and right roots, 5 and 6. Okay, now the for loop is completed. Now index value will increment to 3. See, index is increment to 3. Okay, now again it will check for 3. Index is 3, right? Now the queue is 4 and the queue size is 1, 2, 3. 3 elements are there. So now the size is 3 here and the n it takes 4 node. Now for 4 no elements are there, so it will not do anything. And again size is 3, right? So 3 times it will loop in for loop. Now the n value is 5. It will take the 5 node. For 5, 7 is there, so it will add into the queue 7. 5 will be removed, and then again 6. It will take 6 because 3 times it will loop now because size is 3. Okay, I hope you are getting. Okay, for 6 there are no elements, so 6 will be removed. Now index is 4, incrementing. So here you can see depth and index are equal. When the depth and index are equal, the element which is present in our queue, it should be returned. Okay, now our element which is present in the queue is 7. We can return 7 itself. So here you can see, here we can return queue dot poll dot value. Return 0 here. Let's see. It pass. This is my approach. I use level order traversal technique. First I find the depth, and then with the depth, if my index is equal to the depth, means I'm just returning the QL. The number which is present in the queue. This is how I am approaching this problem. If you find any other optimized approach, means please feel free to comment. It pass. Please feel free to comment. I'm open for learning. Thank you so much for watching up to here. This is the way I randomly think to solve the problem. Okay, I will see you in the next video. Thank you so much.